Assalamualaikum. We are from Group 4, want to present about AM modulator transmitter. First of all, my name is Muhammad Afiq bin Rosli with metric number TB18059 and my members is Muhammad Hafiz bin Zulkifli with metric number TB18049 and Nur Faziratul Akmal binti Roslan with metric number TB18048. For the next slide, the amplitude modulation transmitter. The amplitude modulation mix the modulation signal and carrier signal to produce a modulated signal. The results are shown in each output waveform, which calculation of the mixing between information signal and carrier signal. As stated in this slide, the information signal is 4 kHz and for the carrier signal is 3000 kHz or 3 MHz. Okay, next is the detail of the problem. First is the implication of a sine wave with high frequency are altered directly in relation to the modulated signal. Next is the modulation signal compresses the desired message or information which occasionally such as AM radio transmission. And then the waveform, the information signal, the carrier signal and the modulated signal. Next is comparison of the AM transmitter. The advantage of AM transmitter is easy to be implemented, can be demodulated using a circuit by a few components. The cost required cheaper than others. For the disadvantage of AM transmitter is not efficient with respect to power usage and bandwidth, susceptible to high noise level because mainly amplitude based and sensitive AM detectors. For the next slide, Hafiz will continue the presentation.
Thank you, Afiq. Okay, so this is the function of each component. So firstly, information signal will injected to the modulator with the carrier signal and will produce the modulated signal as an output. So for the description of the design, first we design the Colpit oscillator. Second, we use the AM modulator circuit, and third is a power amplifier. So let me show you the circuit that we have designed. Okay, first of all, I would like to show the waveform that we get. So this is our waveform that we get. So for the 4 kHz that we know as information signal, and the channel 1 is the modulated signal. Okay. So what is oscillator? Oscillator is a device that produces oscillation. Oscillation is generate repetitive waveform. So in oscillator, it will divide into two type of oscillator. First is untuned oscillator and tuned oscillator. For the tuned oscillator is wind bridge. The untuned oscillator is wind bridge, and the tuned oscillator will be divided into two. What first is Colpit oscillator, then Hartley oscillator. For this design, we use Colpit oscillator. As we can see that we use so much capacitor than inductor. Okay, oscillator is used because the frequency stability is to remain and at fixed frequency, and to modulating information and modulated the signal. Second is AM modulator circuit. Okay, so AM modulator circuit is right here. Okay, modulating is a process to combine or adding two signal, which is information signal and carrier signal. Amplitude will change. Modulator add by carrier signal and modulating signal and come out with a modulated signal as an output. We will see DBSFC, or we can see is double sideband frequency carrier, amplitude modulation with carrier. Okay, process of changing amplitude at a relatively high frequency carrier signal in proportion with instantaneous value of information signal. So the information signal we will tap on the Colpit oscillator. Then the carrier signal is here, and the last one is modulated signal is at the power amplifier circuit. Okay, this is our figure, our circuit design. Okay, next I will give to Fariza.
Okay, next I will continue about the reasoning of design step. In order to create a sine wave of 4 kHz, the information published of the transmitter is a Colpit oscillator. On the tank circuit, which consists of capacitor and inductance, the frequency of oscillation may be determined. So this is the calculation we use for Colpit oscillator, and we get the frequency carrier is 3 megahertz. So same with the waveform at oscilloscope 2.9. So for the implementation with the commercial component, we use this. Stop. So next is the implementation with the commercial component. So we use DC supply to power up the circuit, resistor to control the current flow, capacitor to store the electrical energy, transistor, amplifier signal, and lastly information signal, plug in the information frequency. Okay, for the implementation with the commercial component, we use DC supply to power up the circuit, resistor to control So for the conclusion, we gain so much input and knowledge during this project. We learn about the amplifier. We can now build a circuit that has amplifier at the output. Besides, we understand the waveform and frequency spectrum of AM signal. We can strongly conclude that AM transmitter function to transmit data from source to the filter base, and we get a picture of understanding because we did this project simulate. For the improvement, we can improve our output by using a different types of amplifier that will produce a nice envelope shape figure even after it is amplifier. Other things, we can fix it to make a better circuit as it contributes a lot of factor in producing our desired AM output. Okay, so the contribution of each members. So for the research on this project problems and main idea, Afiq and I, for design and construct the diagram of circuit, we are doing together. Implement with commercial component selection, Hafiz and I also, and finalize the report of Hafiz and Afiq. That's all. Thank you.
Assalamualaikum. My name is Muhammad Akmal Maraini, and my group have to design amplitude modulation transmitter with the information frequency 3 kHz and transmitter frequency 4500 kHz. And we must to first we must to identify the stage of the transmitter system. The first stage of transmitter system is a oscillator, and second stage of transmitter system a modulator, information signal, and a power amplifier. The first oscillator is a device that transforms unstable current flow source to the desired frequency. The information signal is the information is a order sequence of symbols that transmit message in its basic technical definition. And AM modulator is the for double sideband frequency full carrier. AM modulator is process changing the amplitude at frequency, and power amplifier is basic use enhance the power level. And the power amplifier transmit to antenna, and antenna will be communicate long distance. That's all for me. I will pass to Adawiyah.
My name is Rabiatul Adawiyah bint Azmansyah, TB18055. So we continue with design. We have 3 designs, which is Colpitts oscillator, AM modulator, and amplifier. For Colpitts oscillator, we have two connected capacitor in series and 1 inductor in parallel. Next is AM modulator. The type of AM modulator that we use is double sideband full carrier. So we connect the AM modulator with function generator as the frequency carrier that is set as 3 kHz. Design number 3 is amplifier. The type of amplifier that we use is LM307N. The function of this power amplifier is to increase the size of the amplitude. Next is reasoning. We use oscillator because the reason of using a Colpitts oscillator is because it can produce a more pure sinusoidal waveform due to the low impedance. So here we show the frequency of Colpitts oscillator by calculation. The final output frequency that we get is 4.789 MHz. The reason of using AM modulator is because the circuit is simple to implement, and AM modulator can travel longer distance. Lastly, the reason of using amplifier is to boost the amplitude signal. So for the components, we have 2 specific components, which is transistor BC547 BP. There are 2 transistors here. The one is in Colpitts oscillator and the other one in AM modulator circuit. The reason of using this transistor is because it is NPN type transistor. Next is the other specific component in this project is operational amplifier LM307N. This type of amplifier can be found in inverting amplification circuit. The reason of using this amplifier because it enables substantial amplification of M input signals. So I will pass to Iman Hidayat for conclusion.
Alright, thank you. Next, I will be presenting about discussion, conclusion, and also contribution. As you can see here, the first of all is the outcome of the project. On figure 8, you can see the waveform of channel 1, channel 2, and channel 3 basically. 4.55 megahertz, 4.54 megahertz, and 3 kilohertz. the waveform is conducted by using multi-sim software. So the information frequency is set for 3 kHz and transmitter frequency is set for 4500 kHz. The transmission produced is the SBFC, which is the double sideband full carrier. So after we run the simulation, we observe that the frequency is 4.55 megahertz, and the output frequency is greater than the input frequency, which is 4.5 megahertz. As you can see here, this is the percentage modulation index, which already been calculated. So the modulation index percentage is 41.83%.
That is my circuit. That is my circuit that we get with a combination of three stage and oscillator and modulator and amplifier. The output of waveform we get 4.55 megahertz for channel 1 and channel 2 4.454 megahertz and channel 3 is 3 kilohertz. That's all my group. Thank you.
Assalamualaikum. Today, my group, which is group 6, is going to present our CSD project for amplitude modulation transmitter system. My name is Razlan Hafiz bin Ramli. Today, we're going to present with my group members, Faris Imran bin Yusri, and also Nur Zulaika binti Zahari. This is our contents for our presentation today. First, we're going to talk about abstract. Then, we're going to understand the problem towards our project. And next, we're going to talk about our design. And also, next, implementation of components. And conclusion with the discussion. And lastly, we're going to talk about our contribution. Firstly, an AM transmitter is one of the electronic communication system modulation methods. It is a method of implementing data on the carrier waveform of an alternating current. The AM transmitter also transmits information by using a carrier signal. It is used to change the baseband frequency to a higher one, allowing data to be sent over airwaves. So, for our task, we are required to design an amplitude modulation transmitter system with only two information given, which are information signal, which is 4 kilohertz, and we want to transmit a frequency with 4 megahertz. As we can see to our block diagram, by using our information signal, that is what we're going to transmit our signal towards the modulator, and we want to have an output, which is the modulated signal, of 4 megahertz. We are using a function generator to transmit our signal through the information signal. And next, we're going to talk about our design by Faris.
So thank you, Razlan. I will explain about our design, about our project. So our transmission frequency is 4 megahertz and input frequency is 4 kilohertz. So this is our design that includes an oscillator and then modulation circuit, amplifier circuit to progress the process of AM transmitter. I like to share the circuit in the multi-sim. For this part, this is an oscillator circuit. So this oscillator, we use a Colpit oscillator. For this one, this is an modulation circuit. For the next part is amplifier circuit. So when we look from the block diagram, the process will start from the input and then for the oscillator, and then going through to modulation circuit. For lastly is amplifier audio circuit to amplify the amplitude from the transmit modulation. So this is our waveform. You can see. So as you can see here, after we simulate our design circuit, so the channel 2 is our input information signal, which is 4 kilohertz, and then the channel 3 which is an envelope that produce 3.8 megahertz, which is close to 4 megahertz, that will relate based on our task given, which is input to receive 4 kilohertz and the output is 4 megahertz. That's all for me. The next I will pass to Zulaika.
So now I am going to explain the reason behind choosing these specific components. So first we have VCC. It is stand for voltage common collector. It is used to supply input for the circuit. The quantity used is 2. Next, resistor, to reduce the current flow, and the quantity used is 10. Moving on to capacitor, it is used to store energy and release electrical energy. The quantity used is 9. And then we have inductor, to supply energy during the off switching period. The quantity used is 3. And lastly, we have transistor, to amplify the signal. The quantity used is 3. Next, operating detail of selected component, we will go detail to BC107 transistor. It is used to create a low noise general purpose audio amplifier. For the implementation diagram, this figure shows the connection of transistor BC107 in amplitude modulation circuit. Next, moving on to discussion. As you can see, this is our amplitude modulation waveform. On channel 1, we have transmission frequency 3.81 MHz. On channel 2, we have information frequency 4 kHz. And lastly, we have modulated signal frequency 3.8 MHz. Our project is successful as our simulated result are the same as expected result. As conclusion, throughout this project, we have increased understanding about AM transmitter. Second, we have learned how to build oscilloscope circuit, AM circuit, amplifier circuit, and how those circuits are combined into one complete circuit. And then we also understood the function of the component used in the circuit. AM modulation has big contribution in electrical communication system. It became a standard voice transmission. Lastly, we have contribution. This is the table show role of each member. First, research on project problems and main idea are done by Faris, Razan, and Zulaika. For design and construct diagram and also the circuit are done by Razan and Zulaika. Implementation of the components are done by Faris and Zulaika. And lastly, finalize the report are done by 3 of us. I guess that's all from us. Thank you.
Assalamualaikum. Today our project group gonna present about the AM modulation. So this is our circuit. So we have a LC tune circuit and we have a carrier oscillator, and we set the function generator to the 3.5 kilohertz. This is because this is our questions, and we set the amplitude to the 30 dB to make the waveform bigger. The channel 1 waveform is the carrier signal, the channel 2 waveform is the modulate signal, and the channel 3 is information signal. So for the channel 1, we got the frequency about 3.5 kilohertz. Channel 2, the modulate signal 4.13 kilohertz.
And for the information signal, we got the frequency 3.5 kilohertz. Okay, let's see where's this connection goes. Okay, for the channel 1, we connect it to the carrier oscillator, and for the channel 2, we connect to the carrier, amplifier and modulator, and for the last, we connect it to the function generator. So that's all for me. Okay, let's go to the next slide.
Thank you, Mr. Imran. So go for slide Mr. Zul Hakimi. Carry on.
Okay, Mr. Imran. Now I will explain about the slide. Our abstract, we are given the challenge to design an AM transmitter circuit utilizing the frequency that we choose. The basic modulator circuit is used in this project to create a double sideband full carrier system. The frequency that we choose is the carrier signal is a 3.5 kilohertz. The transmission signal is 350 kilohertz. Next is the understanding of the problem. The detail of the system is the process of changing the peak amplitude to carrier and information frequency. The change in amplitude and modulation in double sideband full carrier are caused by voltage. The figure show the waveform shape of a double sideband full carrier. Next is the function of a system component. The block diagram. The signal is from the oscillator and will be sent to the amplifier. And amplifier will send the signal to modulator. Information signal also will be sent to the modulator, and the modulator will send the signal to band pass filter. Next is the design of the circuit. The first figure show the carrier oscillator. The second is the carrier amplifier and modulator. The third is the band pass filter. Next is the reason of the design step. In this project, the device that we choose is to regenerate the basic signal for the AM modulator. The carrier oscillator was choose the oscillator in this project. This is the figure show the calculation. The inductance that we get is 4.55 microhenry. The capacitance that we got is 0.45 picofarad. That's all for me. I will pass to the Mr. Fakri.
So hello, my name is Fakri Mekai Mahadi. So this is the illustrate the design of the circuit. So this is the AM modulation circuit that we have done in the report, and the circuit using multisim. So the circuit is designed by Imran, and the idea come from me and Zulhakimi. So the contribution work is well done. We contribute the work one by one. So next, Imran. This is the component that we use. The DC supplies, one quantity transistor, 2N3900, resistor, tank, capacitor, inductor, oscilloscope, and function generator. So all the list that component you have done and used in our circuit and modulation circuit. Next, Imran. For the discussion and conclusion, we got the carrier signal and information signal at 3.5 kilohertz, and the both signal is the same, but it maybe have wrong or right, because the frequency may be high, maybe low, from different from our report, because the multisim or our mistake do the wrong circuit, or maybe not. And the blue, the channel 2 is the AM related waveform. We don't get the envelope, but we have done a little bit, and we can see the emulated waveform without LC tune circuit is there are no waveform. It's straight line. When we use the LC tune circuit, we got the waveform. So on the channel 2. Next, Imran. So the improvement that we can make is we are facing the value of DM is larger than BC, so it's affect our frequency and maybe have some distortion on the signal, including the tune circuit. We need the precise value to make it better. So for conclusion, the AM transmitter is we are able to understand the AM principle, where is the information signal, where is the carrier oscillator, where is the modulated signal, how to do the work and contribute the work one by one. So next, Imran. So the contribution work, yes, this is research and main project. This from me, Fakri, Imran, Zulkimi. We contribute the work well done, one by one. Next, Imran. So the reference we got from the Rochester Electronic, then Manjo Electronic. We search the project from the Google book. We don't have the book, but we Google and search the book. From that, we do our project for our reference. Next, Imran. So that's all from us. Thank you. Bye bye. Assalamualaikum.